Okay, students, so I'd like to introduce this week's experiment to you. So we have our usual setup going over here. We have a Cesium-137 source way up there on top of the detector, and it's doing its usual thing here. We have the usual varying voltage pulses in here, and we have the SCA output, single channel analyzer output on the oscilloscope too, in terms of the little green pulse you see sitting there. You can zoom in on a bit more, you can see the green pulse. And we have the lower level discriminator on the SCA set for no particular reason here, lower level discriminator set to give us about 652 counts per second of the gamma rays coming in. That's about the level that we did in the high and low count rate experiment that we did in the past. So the question we're going to ask in today's experiment then is, all right, so suppose you have these counts coming in, 650 counts per second, 638, the number varies a bit. The question we'd like to ask in this lab is, once you get the delivery of a gamma ray, say one gamma ray comes in, how long do you have to wait until you see the next gamma ray? And then from that one, how long do you have to wait to see the next one and next one and so on? In other words, we'd like to categorize, sort of from a number like this, what is the waiting time between arrival of gamma rays? So what we're going to do in this experiment, something kind of unusual here, is we're going to go down here to the SCA pulses. We know the SCA pulses are an indicator of the presence of a gamma ray. So as I run it here, there's an SCA pulse right there. As I run it again, there's another pulse right there, and another pulse. So these SCA pulses keep showing up at a certain amount of time when a gamma ray arrives. And these pulses, to me, are always kind of interesting here because they have all the usual characteristics that if you sort of know some things about electronics, you're kind of going to like. So I'm just zooming in on one of these green SCA pulses here, output in a minute here, or as we see here. So what we see here is the pulses here are approximately about 2.5 divisions here on 2 volts per division. So these pulses here are approximately 4 to 5 volts in height, and they last horizontally there for about 500 nanoseconds. So we have a nice square 5 volt pulse coming out of the SCA, and of course that represents the presence of a gamma ray. So what we'd like to do is see when a pulse arrives like that, and as soon as the pulse arrives, start a timer, and then let it run and see when the next pulse arrives, and then stop the timer, and that'll be so many seconds. And as soon as that pulse comes in, start the timer over again and wait for the next pulse, and the next one, and the next one. In other words, we like to just continually time the time interval between those SCA pulses coming in. So between the SCA pulses. So there'll be one like this gamma ray gives this one, and I can't quite do it on the oscilloscope here at the moment, but there would be another gamma ray here that would give another green pulse, and as you keep going, another gamma ray, another green pulse. We'd like to see what time distribution exists between those pulses. That's what this lab is about. The waiting time between gamma ray arrivals. Okay. And of course that's going to be related somehow, to this number right here. So you probably want to remember that as this experiment runs here, we're sort of getting, somewhere around, let's say, 650 counts per second on average. That'll sort of be a conclusion we'll come up with for our lab. Okay. So the way we're going to do this then is, because these pulses, as I said here, have these sort of well-defined characteristic, as I mentioned here. They're 5 volts, and they have some on time there. These are just ripe to be interfaced with all kinds of electronics, because electronics at sort of the basic level also operates on 5 volt pulses of some width and that sort of thing. So we don't really have anything in the software or made for us to do this timing between pulses for us, but what we can do is we can take these output pulses from the SCA that we're looking at on the oscilloscope, and we even fed into the black box here, and we can feed it into something called an Arduino here. And what the Arduino is sort of our own little computer that we can sort of tell to do whatever we want with. So I will pick this up in the next video, exactly what we're going to do.